So when you're considering a chemical reaction, we've been asking so far in this class whether the reaction will go spontaneously. So we've been talking a lot about thermodynamics. We've been talking a lot about delta G. But we also need to consider how fast a reaction goes, and that's kinetics. So a kinetic experiment is one in which you measure the rate at which something's happening, the rate at which a concentration is disappearing or whether the rate at which a concentration is forming. You're measuring some kind of change of a reaction, change in composition versus time. So I'm going to give for an example of why kinetics are important, talking about the oxidation of glucose. And I'm going to ask, we're going to do a little experiment, and I'm going to ask the TAs to help me. Everyone needs to have something to do an experiment with, something that might have some glucose in it to do this experiment. So if the TAs could help me hand out the ingredients for this experiment. So, don't open your experimental apparatus until I give the okay. So just collect it, and let me set up the experiment for you while we're handing things out. So you're all familiar with this reaction. So we have glucose and oxygen go to CO2 and water. And so we've talked a lot about delta G for this reaction. And delta G, again, is equal to delta H minus T delta S. So for this particular reaction, we have a negative delta H naught. So what does negative delta H mean about this reaction? It's exothermic. Delta S naught is positive. What does that mean if delta S naught is positive? What's increasing? Entropy or disorder of the system, which is favorable. So our delta G naught is a big negative number. So in terms of thermodynamics, what does this mean? Is this reaction spontaneous? Yes, it's very spontaneous. It's very thermodynamically favorable. Now, when glucose in products are wrapped, they're often wrapped under a nitrogen environment. So oxygen is not sealed up in this container, in the wrapper. And they do that to prevent bacterial contamination and things like that. So the glucose that would be in a wrapped candy is not exposed to oxygen. And so if you look at this thermodynamic information up here, one might imagine that if you ripped this open and oxygen came in, that there might be some kind of level of explosion with CO2 coming out and water coming out. Now, you might say, well, if you have one, sort of little thing, it might not. But now, if everyone has one, and we all open it at the same time, what do you expect to happen?